Okay, let's dive into this. I want you to imagine an object so incredibly powerful that space itself literally bends around it. A place where time actually slows down, and the fundamental laws of physics, well, they just start to break. We're talking about something so massive, so gravitationally dominant that it completely challenges our everyday understanding of reality.
Now, you might be thinking we're pitching the concept for some new science fiction blockbuster, but I assure you this is entirely real. Today, in this explainer, we're going on a real-life exploration of black holes. We're going to look at exactly how these cosmic titans are born, what mysteries might be hiding inside them, and what would actually happen if you were unlucky enough to fall into one. Let's begin.
Now, what's really interesting about this concept is how it completely shatters a massive popular misconception. People often imagine black holes as these giant cosmic vacuum cleaners, right? Just roaming the galaxy, sucking up everything in their path. But actually, that's simply not true. If we magically replaced our sun right now with a black hole of the exact same mass, Earth's orbit wouldn't change at all. No, we wouldn't get sucked in. We'd continue orbiting almost exactly as we do right now. The only real difference, we'd be completely in the dark, with no sunlight to keep us warm. So if they aren't vacuum cleaners, what makes them so dangerous? Well, it all comes down to the event horizon. A black hole is a region of space where gravity becomes so immensely strong that absolutely nothing can escape once it crosses this specific boundary. Think of the event horizon as a cosmic one-way door. You can walk through it, sure, but there is absolutely no known way back into the rest of the universe once you do. How does something like this even come into existence? Stellar black holes are born from the spectacular deaths of massive stars. It starts when a really massive star simply runs out of its nuclear fuel. When that happens, gravity, which has been trying to crush the star for millions of years, finally wins the tug of war. In an instant, the core collapses in on itself, and the outer layers are blasted away in a stunning explosion known as a supernova. If that remaining collapsed core is massive enough, it just keeps collapsing, packing more and more mass into a tiny space until, boom, it forms a black hole.
But it doesn't stop with just dead stars. Scientists also study these absolutely giant entities called supermassive black holes. And when I say giant, I mean they contain millions, or even billions, of times the mass of our sun. We find these titans sitting at the very centers of most large galaxies, including our own Milky Way. Though exactly how these incredible giants originally formed, that is actually still one of the most exciting and active areas of astronomical research today.
Which brings us to a rather terrifying but fascinating hypothetical question. What happens when you cross the event horizon? Imagine for a second that you are drifting in a spaceship, falling toward this invisible cosmic boundary. What exactly is going on around you?
And this brilliantly illustrates what physicists call the waterfall analogy. The best way to understand this experience is to think of a river near a massive waterfall. When you're far away, the current is gentle, right? Escape is totally possible. You can still safely swim back to shore. But as you drift closer, you pass a certain point where the current simply becomes unstoppable. The event horizon is exactly like that invisible boundary in the river. Outside it, you can escape. But inside the boundary, the current of space-time is flowing inward faster than the speed of light. Every possible path, no matter how hard you swim, leads deeper inward.
So what happens to your body as you fall deeper? Suppose you fell in feet first. At first, near a very large black hole, you might not actually notice anything unusual right away. But as gravity becomes significantly stronger closer to the center, the gravitational pull on your feet becomes radically greater than the pull on your head. Your body would literally be stretched longer and longer, thinner and thinner. Scientists actually call this extreme physical process spaghettification. I know, it's a funny word for a pretty brutal reality. Eventually, these tidal forces become so severe that no known material in the universe, and certainly not the fragile human body, could survive intact.
So the crucial point is that whatever falls in is destroyed, right? But that begs an even deeper question, one that moves this explainer from the realm of classical physics into the bizarre, mind-bending world of quantum mysteries. What is actually inside at the very center of a black hole?
Well, at the core of a classical black hole, Albert Einstein's equations predict something called a singularity. A singularity is a theoretical point where density becomes practically infinite, and our current laws of physics, they just throw their hands up. The math literally stops giving reliable answers. Most physicists believe this mathematical breakdown is a massive red flag. It signals that we need a brand new scientific framework, specifically a unified theory of quantum gravity, to fully describe what is actually happening there. Because of this, the true nature of a black hole's interior remains one of the absolute greatest unsolved mysteries in all of science.
Let's move on and see how this builds into a fascinating timeline of human discovery. We haven't just been sitting around guessing. Back in 1974, the legendary physicist Stephen Hawking made an astonishing mathematical prediction about black holes. Fast forward to 2019, and humanity achieves what was once thought impossible, the very first image of a black hole shadow, located in the galaxy M87. And not long after that, astronomers captured an image of Sagittarius A star, the supermassive black hole at the heart of our very own galaxy.
Let's look a little closer at that first major milestone. Hawking figured out that black holes aren't completely 100% black. Thanks to weird quantum effects occurring right near the edge of the event horizon, black holes actually emit an extremely faint form of radiation. Over unimaginably long periods of time, this radiation process causes the black hole to slowly lose mass. Eventually, in the deep, deep future, they will completely evaporate. But don't worry about them disappearing anytime soon. For a stellar or supermassive black hole, this evaporation process would take far, far longer than the current age of our entire universe.
And speaking of milestones, we absolutely have to appreciate the Event Horizon Telescope collaboration. Capturing the unseeable shadows of M87 and Sagittarius A star was an incredible global feat of engineering and data science. Hundreds of scientists linked up radio telescopes from all across the globe to essentially create a camera the size of the Earth. These remarkable achievements did something profoundly important. They provided actual photographic evidence that confirmed decades of theoretical predictions about exactly how black holes bend the light around them. So, why does all of this matter to you and me? Well, black holes are not just terrifying cosmic monsters lurking in the dark. They're actually the ultimate natural laboratories. They represent the extreme frontiers where gravity, space, time, and quantum physics all violently crash into one another. They continually challenge our fundamental understanding of reality, and they hold the critical clues we need to unlock the deepest underlying laws of our universe. Honestly, the more we study them, the more wonderfully mysterious they seem to become.
As we push our technology and our minds further into the dark, we have to ask, if black holes hold the ultimate secrets to space and time, what reality-bending truths will we discover when we finally unlock them? Perhaps one day, they really will reveal the secrets of space and time itself.